Okay, we had our science critic also. Okay, fellow who made a video, and his video criticized the scientific method. Can you believe someone today in this day and age criticizing the scientific method? Okay, yeah, unbelievable. Anyways, this is what he had to say. He talked about fields in space-time. And again, it's got a little bit to do with what I just explained a little while ago. Okay, so let's see what this guy has to say. Here goes. Listen carefully. The issue that is addressed here is that this fellow confesses that we cannot even hope to grasp fields and space-time. Yet he claims that he understands physical interpretations founded upon them.
So the thing is, there is something there, but it's not the type of thing that our brains can easily comprehend. Our brains have evolved to deal with matter. Things like fields and spacetime seem completely foreign to us. But then when you learn and study about these things, it makes it easier to understand what is actually happening.
Yeah, it makes it easier to understand what's happening when you don't know what a field is. Okay, so we don't know what a field is. We can't conceptualize it. But once you learn about these things, oh, you understand everything. Yeah, because you could understand everything as long as you introduce spirits. Okay, you say the spirit did it. Oh, okay, so we're done. What else is there to learn, right? And first, let me address the issue of comprehension. Okay, we do not comprehend things. Okay, here we have a rock. We don't comprehend a rock. Okay, we don't understand a rock. Okay, you understand or you comprehend when someone tells you a story or a theory. Maybe he tells you the movie that he watched. Then you say, oh, I comprehend. I understand what you explained just now. Okay, or described or whatever. But when you just point and say rock, there's no comprehension there. It's called visualization, imagining. I can even, once you know what a rock is, I can say mention the word rock. You don't have it in front of you. I don't point to it because we don't need to do that anymore. You just say rock, and you imagine, okay, I know what he's talking about. He's talking about a little thingy there. Maybe your rock, the one you're imagining, is a little different than the one I'm imagining, but we're both referring to the same thing. I say tree, same thing. You say, okay, I know what a tree is. Okay, we all imagine the same thing. So we do not comprehend objects any more than we define objects. We point to them and name them so that the ET learns our language, learns the nouns. You point, say coconut. You're both stuck on an island, say coconut. Now he knows what coconut means. It's that thing there. There's no real comprehension in the sense of, a story, a theory, something that, that is lengthy, a paragraph. Did you understand the paragraph? That's different than when you read it, right? This is different than pointing and saying, tree, rock, chair. There's no real comprehension, not in a scientific world, and maybe in the ordinary speech world, but not in the scientific world. Okay, so the question is whether a field is a thing, because he mentioned that several times. In fact, he said, there is some thing, meant the field, right? There are things there. Things like fields seem completely foreign to us, yeah. But when you learn about these things, it makes it easier to understand what is happening. He concedes that field is not matter. Okay, so it's not matter. He says it's not a thing. What is it? What are we talking about? And so the question is, thing that which has shape. We define it very simple, very baby-like. In fact, that is the scientific definition of the word thing, because every thing in the universe has shape, and that which is doesn't have shape is not a thing. Okay, that's how simple it is. An object, thing, entity, structure, any of those words, substance. They're all the same thing. They're all the same synonyms as far as physics is concerned. Okay, every word in the dictionary either has shape or doesn't. And if it doesn't, it's automatically put in the category of concepts. Okay, shape is a static concept. You don't need to have any motion in shape. And a lot of people get so confused with that. They say, well, everything is moving in the universe, so everything changes shape. These people, I say, are mentally retarded. That's the way I treat them. Because shape is a static concept. And we have to look at a cross-section of time. And people don't understand that. Okay, so, but what did Maxwell say about field? Okay, the space in the neighborhood of the electric and magnetic bodies. In that space, there is what? Matter in motion. Matter in motion. So a field does not have shape because field is matter in motion. Something is moving inside a field, and you see that on the right, lower right there. You see that a field, so-called field, is not a physical object. What it is, it's made out of something that is moving in that area, and for a magnet, it is underwater. It pulls every iron filing one at a time towards the magnet. So a field is something in motion, matter in motion, and it pulls one iron filing at a time. What you have to identify is not the field, which is that whole region in where something is moving in there. You have to identify the thing that is moving. That's what you have to, that's the thing, not the field. Field is a concept. In fact, it's worse because, as you can see on the upper right, the definition of field is a quantity that has a value for each space and time. So all we're talking about when we're talking about a field is a bunch of numbers. What is the number? Well, what they do, they measure the strength of the field, the strength at each place around the magnet. And they say, okay, the field has a certain strength here, another strength over here, and they map all these strengths, right? And they do that, and you can do that physically with iron filings. And they say, okay, we see how strong the field is, and the farther away you get, as you can see there as well, fewer and fewer iron filings stick to the thing, and it gets lighter and lighter as far as iron filings are concerned. What you have to identify, what matter in motion, what matter is moving inside that field. And until you do that, you won't understand this. You won't understand what a field is. Okay? And so let's quickly educate this poor critic, okay, who doesn't know what a field is and says he understands everything. Okay? And here it is. Here we have a running gal. Okay? So she's running, she's moving, and we always say, okay, that's more or less like a field. It's got all these parts and they're all moving. Okay? But what's the issue? Here, let's stop her. We're gonna look at the universal movie here. So on the top, what you see is the gal running, but on the bottom, we've separated each one of the frames of that film. And what we're saying is that in each frame, nothing at all is moving. There's not a single electron that is moving in that image. In other words, we're talking about a real live image. If we talk about an actual gal that's running out there, and we take, and God were to stop the universe, okay? Here we'll get God to stop the universe, okay? So he waves his magic wand, and now nothing moves in the universe. In fact, God had better not move either, because otherwise we'd be moving with respect to him. So we're going to stop the universe. No motion whatsoever. Not a single electron moves, because we have a cross-section of time. We have what we can call a frozen universe. It's frozen until someone, melts it again, okay? Defrosts it. It just stays in that condition. Okay, so there's nothing moving in a picture, in a photograph. And it's so hard for all these people to understand, because they get sidetracked. They say, but everything moves in the universe. We're stopping everything. We're saying even the electrons don't move. Nothing moves. And they don't understand that. They don't understand the assumption that we're making. We're saying, look, let's assume we stop everything. And that's what we're seeing in one of those frames. Okay, what if we stop a field? Okay, this fellow talked about a field. And we have Maxwell, he says there's matter in motion. Okay, what if we had God's eyes? Someone mentioned that at the beginning of today. What if you had God's eyes and you could see that invisible world of Mother Nature's there, what she uses to do her magic tricks? Okay, what is it that's moving in a magnetic field? Just an example. Okay, so we have a magnetic field. What did Maxwell say? Matter in motion. We take a snapshot. We have Atom Man. He can see at his level. Let's see what he took a snapshot for us. Nothing is moving, no electron, no atom, nothing in the entire universe is moving. He just took a snapshot for us. Okay, this is what I say we would see. Okay, here it is. Magnetic field is comprised of countless threads that are swinging around. Here we show a single image, and obviously I didn't illustrate all the threads. Okay, but what we're saying is, if we were to take a snapshot of a field surrounding a magnet, or two magnets like in this case, what we would see is the pattern formed by threads that are swinging around. If you take a mere snapshot of that, well, you would see just threads just standing there, frozen in time. Okay, and so that's the matter that was in motion that Maxwell was talking about, that he couldn't figure out. He did not understand why there was something in motion in there that he could not see or touch. And we're saying that you cannot see or touch the threads that swing around a magnet. Okay, so hopefully we answered what a field is. And yet, field itself is not a what. Field is a bunch of numbers. It's defined as a bunch of numbers. And even from a physical point of view, all they're saying is there's matter in motion in that region they call field. Until you understand those two concepts, you're going to be using the word field all the time as a physical object. You say, the field did this, it moved a charge, or banged a charge. You can't talk like that in science. You can't talk like that in physics. You can talk like that in mathematics.